Hi, my name is Barbara Alishoff. I worked at the FDA for 5 years, from 1995 to 2000. I'm a statistician. And then I worked in industry as a consultant for 12 years and then started my own software company, and we create software for clinical trials industry to review their data, basically. These are the learning objectives, and they're exactly the same as what's in the syllabus, except I reordered them because I wanted to start with talking about key risk indicators and different types of key risk indicators. Transcelerate is a group of pharmaceutical executives who have tried to solve some of the more challenging problems in the clinical trials industry. And one of the problems they're tackling is risk-based monitoring. They wrote a position paper and 2 follow-ups to it, which I recommend you reading. They outline for you exactly how to go about doing it. Their main point is that using risk-based monitoring, you're going to find procedural errors in the data. When you do 100% source data verification, you can't find those. You need to look at the data as a whole, centrally, not each individual point. And they tell you you need to, ahead of time, set up these things called key risk indicators, monitor the data throughout the study for these key risk indicators, and then modify the plan to adapt to the data. An example of a key risk indicator that they put in their paper is this one that I have here on the slide, where you look at the average reported adverse event rate at each site, and you look for sites that are more or less than the average of the sites. And if you find a site while you're looking at the data throughout the study, if one site falls above or below 5%, more or less than the average site, then you assess the data remotely. If it goes beyond 15% of the average reported adverse event rate, then you assess the data remotely, call the site, and visit the site. And it depends, the action that you take depends on what you find when you assess the data remotely. And then they also recommend, as you're going through the study, looking at these risk indicators, you might decide to modify your plan, change some of these thresholds to be more or less strict. And the thresholds themselves depend on how the key risk indicator impacts the primary objectives of the study. So, for example, in a blood pressure study, you would have a very small window for error on the blood pressure measurements. Your 5% might be changed to 2% or 3% on blood pressure. But in an oncology trial on blood, you wouldn't be so worried about blood pressure, so you might expand this to 10% on blood pressure. Okay, so the other thing that Transcelerate people recommend is only looking at the critical variables, the critical fields. And these are fields that impact the primary safety objectives of the study and the primary efficacy objectives of the study. And they're saying that because we collect so much data, and it would just be impossible to check every single value at this point. 10 years ago or 15 years ago, we didn't collect as much data, and it was possible to do it. But now it just is putting an enormous strain on the system and increasing the costs of the study. And I agree with that you shouldn't check every single data point. However, I think that you should monitor every single data point centrally. You should, not that you should check every data with the source, every data point with the source, but you should at least look at all the data as a whole, because you are collecting it, and you're collecting it for a reason. I think you're going to use it at some point in time, maybe for publication, or maybe you're just using it to make sure the critical fields make sense. But it's being collected for a reason, and if it's going to be used, you want to make sure it's correct.